Good.
Let's see. Back to school. You guys already have the quiz up and everything?
I opened it, yeah.
Okay. I'm coming.
You're fine.
I really like it when they give us just like a plain formula that we can just always use. Like they did in the lesson. Isn't that so much nicer?
Yes.
Yeah.
All right, I'm here.
Okay, so first 2 questions, cakewalk.
Oh, yeah, first 2 questions done. Check.
Shall I start with number 3?
Sure.
Okay, it says find the margin of error for a 90% confidence interval when the standard deviation is 50 and n equals 25. Round to the 3 decimal places. So
you just do the z-score times the standard deviation over the sample, the square root of the sample.
Margin of error. Standard deviation. Okay. 50 divided by 5 equals. Margin of error.
So I got 16.45.
Me too.
So did I, but I can't believe that I did it right. So that's amazing. Okay. It's a miracle.
Okay, and the 4th question says, which of the following statements is true? I think that it's the second one.
Yeah, X is a point estimator of U.
Yes.
Yes.
I agree.
I also agree. Hooray.
So question 5, there's that information there. Says, what is the point estimate for the true GMAT score?
Which that's just X, right?
Yeah, 526.
No error for 95% confidence.
Sorry.
Solid.
That was a fun.
Okay. What is the margin of error? So we need to go 95%.
The normal applet, which is 1.96, right?
Right. So in order to get the margin of error, we have to go back to 1.96 times back 113 over the square root of 64.
It's 14.125.
Okay. 113 divided by 8 equals times 1.96. Oh, I did something wrong.
What did you get?
I deleted it. Just a second. Okay. So 113 divided by 8, 14.125. And then don't we have to multiply it by 1.96? Okay. So 27.685.
Yeah.
So I didn't do something wrong. I just don't. You guys, being on meds for the last several weeks, I'm totally clean now, and I feel like I have half my brain again. But I feel like I'm so far behind, and it's just really, I don't trust anything. So we're just gonna keep on working on that. What is the lower? I'm not, but you know what? I'm not doing great in any of my classes, and I just feel behind in everything, and I'm just like, it is what it is. Heavenly Father has a plan. I'm just gonna try to get myself caught up, and gonna be okay. All right. What is the lower limit of this confidence interval?
So then you just do the equation. You
minus,
just do the
right?
margin of error minus the whatever x is.
Yeah, the 27.685.
Mm-hmm.
So x is 526 minus. Okay. 27.685. And we have 498,315.
Yeah.
Yep.
498.
And I want to know the upper limit of the confidence.
Just go the other way. Yay. Okay.
Mm-hmm.
So basically, now we're just doing what we were doing with the little whatchamacallit, the normal curve, right? Except for we're doing it without the curve.
Yes. I guess I don't understand what you're saying.
I don't either. It made sense in my head until I said it out loud, and now I don't know what I'm trying to say. So
for number 8, we got 553.685.
yes, ma'am.
Okay.
What would
It's a miracle.
You've got this.
But I'm getting there.
What would happen to the width of the confidence interval if Gina increased the sample size?
It would
Okay, these
increase.
ones I'm a little sketchy about.
Okay.
I tried to get them, but I mean, there's a lot.
Okay, so I was just reading in the assignment that the hospital didn't want to increase the sample size because they didn't want to increase the margin of error, which means if the sample size is not, if the sample size is not large enough, the confidence interval will be too wide. So we actually need to have it, if it's larger, then the confidence interval gets smaller.
No.
I think it's the other way.
The other way around. Because remember, when we take a bigger sample, we are closer to the actual mean or whatever it was in the theorem of whatever one of those two theorems that it was.
Right.
So if we increase our sample, then our confidence is going to get bigger because we're more.
Oh, you're right. I don't know why I said that backwards. You're exactly right.
There is a scenario where it would be like if we if we increase something else, then the confidence interval would go smaller, but I won't remember it until we see it.
Okay. What would happen to the width of the confidence interval if Gina changed it to a 99%? What are we at? 95%. So the width would get smaller, right?
If the z-score changed or the confidence interval increased,
it would also increase because now we've got a larger margin of error. We've got a bigger space to put it in. Our confidence interval is bigger.
I thought that makes it so we have a smaller margin of error now.
Yeah, I would think it would be that the space would be smaller.
I don't know.
So we had a 95% confidence interval, and that led us to have a 5% margin of error.
But now
So
we
now
have
if you increase the confidence interval, wouldn't that decrease the width?
Yeah, I think it decreases the width. Like it physically makes it smaller.
Let me see. So we've got our.
Does it?
Part.
So then we have. Oh my gosh.
So if you put it in the normal probability, the little applet, right?
Right.
Our three. We've got our list on the reading. We've got our three common ones. So 1.645 is 90, 1.96 is 95, and 2.576 is the z-score for 9%. 2.56 is the widest.
You're right.
Of the three.
So it actually gets fatter.
Right. We're increasing our confidence level, so it's getting bigger.
Okay.
Yeah. Okay.
Right? The more confident we are, the wider it is. The less confident, the smaller it is.
Yeah, it just seems counterintuitive, but you're right.
Mm-hmm.
Okay, so there's a bunch of information there. What sample size do they need? So now we're doing the other equation, the n equals z-score times the the standard deviation over their margin of error.
Yes.
Where the heck did I write that?
I'll be right back.
Just a sec. I got to write that equation down because for some reason I didn't. There it is. X. Oh no, that's plus or minus. Huh.
Can't quit spazzing. So.
M equals, there we are. Margin of error. M equals the z-score. Okay. I don't know how. Okay. Back to here.
So I got 246.
I'm catching up with you real quick. 90.
So do we, I'm sorry. So does it want us to do, if it wants us to do 95%, then we need to use that z-score 1.96, right?
Yes.
Okay, 1.96. And 100 over, we don't know.
What did you say you got, Ty?
I got 246.
I got 16.659. So there's something wrong there.
Times 400.
Okay, so what do you do? Let's do it again.
Just a sec. Where is that? Oh, I'm on the wrong page. That's why. Okay, I'm going.
Did you square it?
Yes. But I got you know what happened is I got a weird number for my 50 divided by 1.96 number. That's what happened.
Mm-hmm.
I've got it. It's going to change.
Don't we have to go 400 times 1.96 divided by 50?
Yes.
What? Sorry, say that again.
There's something. If I don't do the formula the way that it's like, I have a certain way that I have to do it or else I freak out. So mine goes in a little bit different order.
Okay, so did you get 245.8624?
Yeah.
Hallelujah. So we
then,
go 246.
Yes.
It's a miracle.
There we go. Got it.
Okay. You guys good?
We round up automatically, right, with this guy?
Yes.
Yeah. Woohoo! Okay.
Because we can't have point whatever of a person or of a study or whatever, so you always have to round up if you in your sample on that one.
Okay. So there's a bunch of information.
Okay.
Lower than 25% confidence interval.
So now back to the confidence interval. We want the margin of error, right?
Yes.
Correct.
95% was 1.96. Why am I flipping back and forth? Just open both pieces of paper, Jenny. 1.96.
Thank you for the nice numbers.
Oh, that's not it. 36.730.
Okay. I got 99,002.
Oh my gosh, I'm such an idiot. I just did that whole formula with the level of significance instead of the standard deviation.
1.96 equals. I did not get that. So let me figure out what I did wrong. All right. The margin of error is the standard deviation times the mean over the number, over the square root of the number, right?
Yes.
No.
Yep.
So you have to find the confidence interval, you do the margin of error. Wait, yes, you did. You said that right. I'm thinking of something else.
So
You said that right.
1.96 times 36,730 over the square root of 36.
Are you putting parentheses in there?
Yes. I don't know what I did. Okay, we're going to do it like this. 36,730
Divided by 6.
divided by 6. Yeah, that's what I did.
Good.
And then times 1.96 equals 1,199. Oh, duh. But then what is the lower limit? Oh, Jenny. Ugh.
Did you get 1,000 or 11,000?
11,998. But then I have to figure out, you subtract that from 111.
Yeah, 111,000.
Yeah. 111,000, 99,100 and blah blah, or 99,001. Yeah, I did right. I just didn't round to the nearest whole number. Okay, and two. $99,002. I did it right. I just didn't subtract it.
So now we need to find the upper limit.
Now
is
we
it
just
9,000 or is it 88,000?
Where?
I got 88,000.
Did you subtract it twice?
I I shouldn't have. Let me double check that. I could have. 100,000 minus.
What kind of witchcraft are you guys doing?
Now I have to do the whole formula again.
No, we got the same.
I know, but I didn't write the stupid thing down.
Oh, I'm sorry.
That's okay. 36. It's okay.
So you got it, Abby?
Do it twice. Divided by 6 equals times 1.96 equals. Okay, 11,998 blah, blah, blah. Plus 111,000 equals $122,998.
I'm still confused about the 99,001 number.
What do you mean?
Well, 11,000, excuse me, 100,000 minus 11,000 would be 89,000, wouldn't it?
No, but it's not 100,000. It's 111,000.
Yeah.
X is 111,000. Aren't we supposed to do it from that?
Yes. There we go.
Okay.
Nice.
That's, oh, thank heavens. For once, I have my brain straight.
Yes, and I am the one that's totally tripping.
No.
So are we good on 12 and 13?
Yes. Did you get them, Abby? Or
Yeah, I will have them.
okay.
Yeah. You're gonna make me crazy.
Back. Yay! The last question is easy.
Oh.
It's not even trying to be tricky or anything.
Are you sure?
Well, I don't know.
Just kidding.
I don't trust anything anymore. Anything anymore.
There are 3 requirements that need to be checked when computing a confidence interval for a mean. They are.
It's all the above.
No, it's only one of them because it's like that's the question. That's such a dumb thing. Not dumb, but it kind of is.
But it is all of the above.
It is.
Okay.
No, like the question is kind of they're trying to be tricky, but it's like
that's why I'm like I doubt myself. Okay, I'm gonna submit my quiz. We'll see how we did.
Do it.
Oh.
I did it. We did it. Oh, half a point. Oh no, that's all it was supposed to be. Oh, I missed one. What happened to the width of the confidence interval?
We got that one wrong.
I'm sorry, guys. That one's my fault.
Oh, no, because we believed you and we don't know, so.
Well, I mean, leading the blind here. Let's see.
What you said made sense.
I know. So why is that? Why would that decrease?
So let's say you increase the sample size from 36 to 100.
Oh, you know why? Because we're narrowing it down. Once we figure out we have a bigger sample size, we know that the what's going to happen is close to what we get. So we don't need as big of an interval. It decreases because we're narrowing in. We know that we're getting closer to what it should be.
We just thought about it differently.
Yeah. See, that's what I just was thinking of it the other way around. So, but that makes sense. If you want to clarify, in the lesson 4.2, it talks about the width of the confidence level. So
I have to review that.
Yeah, I just went back and looked at it again, and I'm like, that doesn't. But you know what? The nice thing about totally tanking your classes for the first 5 weeks is that you're going to be okay because you're going to get a B anyway. So if you miss one, you're just totally over it. And I used to not feel that way. It's shocking to my brain to be in this place, but here I am. So, all right.
Well,
All right, guys. I gotta go.
Thanks.
Thanks,
See you
guys.
guys on Thursday.
Bye.
Bye.